Hey everyone, and welcome back to the channel. Today I want to talk about something from Google called Antigravity. My whole problem with the RISC-V chip programming stick is still stuck. So I figured, why not check out the features of this newly released AI? If I can get AI to majorly simplify the time I spend writing code, that just means more time for me to goof off with other stuff. When I first tested Antigravity, I thought it was pretty amazing. It genuinely managed to set up a basic speech recognition function in about an hour and a half, which is way faster than me trying to hunt down and study example code. Later, I had some kids use Antigravity to build a simple program, and that's when I felt like maybe it wasn't so convenient after all. Yeah, it's easier than building something from scratch yourself. But when I write the code, I make fewer misunderstandings. I see tons of people online reviewing AI features, and I'm always half skeptical. The things I usually want to do are never straightforward. Even just searching the web is a pain. I think if a user doesn't have a clear goal, they'll assume every answer is correct. But the moment you specify what you want to achieve, everything suddenly seems to go wrong. The subtitle file for my previous video about GCC? That was actually made using the first version of the project I created with Antigravity. The AI used speech recognition to turn the audio into a subtitle file. Now, the audio I fed it had super standard pronunciation because it was generated using Google Text-to-Speech, GTTS. But the recognition results were still terrible. Maybe it's not even a problem with the recognition capability itself. It might be that combining technical jargon breaks the context-dependent nature of language. Even though Antigravity managed to generate the subtitle file, I still had to spend a lot of time re-editing it. I ended up rewriting or moving about 70% of the sentences, seriously. To make matters worse, my subtitle editing software was acting up too. The audio timing was displayed correctly, but the video picture was completely blank. I actually had to upload the video before I could start fixing the editing software. I initially thought it was a codec problem. The audio played fine, but the video just wouldn't show up. That software used to work before I messed up my system previously. I figured maybe I missed installing something. Though honestly, I think my system installation this time was even more complete. I was so annoyed by the issue that I started randomly clicking every button in the interface. And finally, I triggered some sort of glitch. The video appeared, but the colors were totally wrong. This was in full screen mode. I tried to exit full screen to see what else I could click, but I couldn't replicate the glitch. I messed around, maximizing, minimizing, full screen, removing the border, basically abusing the window, and then, suddenly, the video appeared again, but it was showing up in the window's border, which was pretty weird. That's when it hit me. I was probably using an older version I had grabbed from Snapdeep. So, I went to the Subtitle Composer developer website, downloaded the newest version, and boom, problem solved. While I was doing all that random clicking and testing, I noticed the program actually had its own built-in speech recognition feature. Since some experts had already built the feature, my motivation to use Antigravity to create a subtitle generation tool dropped like a rock. However, after taking a closer look, the program's built-in speech recognition also had a fair number of errors. I think it confirms my earlier point: technical descriptions often break the context flow. I need to save myself some work, especially since I produce videos using a full written script. Using a different approach might yield higher accuracy. If it works well, I'll definitely upload my results to GitHub so everyone can benefit. Let's quickly review that first project that didn't work out so well. Unfortunately, I didn't record either of the 2 times I ran Antigravity to create a project. First, let's look at the Antigravity project structure. Antigravity basically uses your home directory as its base. Right now, there's a hidden Antigravity directory in the root of the user directory. But the main project records are located in a hidden directory called Gemini. Inside the Gemini directory, there's currently only the Antigravity directory. Since Google plans to turn Gemini into a unified management program, what's often called an agent, maybe future local programs related to Google AI will also be built within this directory. Right now, I only use Antigravity, so that's the only directory here. If you click into the Antigravity directory, it looks something like this. The Scratch directory is interesting. Usually, when you start Antigravity, it asks you to choose a directory. If you forget to select one and just run the command, the project gets saved in the Scratch directory. Let's switch over to my project directory to see what the saved projects look like. I created a fresh, empty directory for each project. The first experimental project was audio_to_str. Inside this project, you can see the AI put the finished product in the root directory. There's also a venv directory, which is a Python virtual environment. The structure inside venv is standard for Python virtual environments. I found 3 versions of Python inside the bin directory, and the other directories were empty. Now, let's check out the second project. The root directory here has a bit more stuff. It also has the venv directory, with the standard bin, include, lib, and lib64 directories underneath it. But the bin directory has a lot more files this time. Since this project's functionality required installing other packages, pip had to be installed too. This means every project starts with a newly initialized compilation environment. This is perfect for when you want to take the whole package and move it elsewhere, ensuring you don't miss any components installed over time when switching projects. Let's go back to the brain directory inside Gemini, Antigravity. There are 2 folders here. Although the directory names look strange, I'm guessing they contain the design process for each of the 2 projects. Clicking into one, I was lucky and guessed correctly. I recognize the names of these main files from the creation process. Implementation_plan.md, task.md, and walkthrough.md. The first project, speech to text. So, what was the concept behind my first project, the speech to text one? It was basically the same workflow I use with my subtitle editor. Listen to the audio and type out the subtitles. However, my process is a bit unique because I have a complete written script. So, I wasn't really doing dictation, I was pasting from the script. My choice of words is probably pretty distinct too. My friends tell me that once they get to know me, they find our conversations funny. But at first, they often can't quite follow what I'm saying. But once they're familiar with me, they know what I mean even if my sentences are backwards. This is likely a big factor in why the success rate for speech recognition wasn't high, even though my input audio was generated by Google's GTTS. Add to that the sometimes unusual combinations of IT-related terms, and it gets tricky. Looking at the implementation plan, I requested the code be written in Python. However, I made a mistake then because I clearly didn't need GTTS, text-to-speech. Antigravity smartly came back and asked if I should be using speech recognition. It was right. After I approved that, it started planning and writing the code. The required steps were analyzed by the AI and placed in task.md. Finally, the AI wrote the entire process, from design to completion, in walkthrough.md. Because the AI creates a separate virtual environment for the project, I have to execute the Python file in the working directory. If I move the completed Python file elsewhere, I run into library linking issues. In this first version, the AI also created a separate text-to-speech tool and tested it first. The test sentence was very short, so the speech recognition to subtitle file seemed okay. But when I used my own script, I ran into major issues. The execution process seemed to be: load the audio, detect pauses, split the audio, recognize the text for each split segment, add start and end times, and then compile the subtitle file. The main problem was the speech failing to successfully recognize the sentences. Plus, when I re-listened to the text-to-speech audio, some sentences were cut off in weird places, which made it harder for the speech recognition to correctly split the sentences. The second project, text-to-audio to SRT. The first subtitle generator didn't save me much time, but it did help me identify the underlying problem. So, I redesigned the workflow based on my existing assets. I feed it the written text file. The program splits the text into sentences, and then sends each sentence for text-to-speech conversion. After that, it drafts the subtitle file based on the sentence length and adds a constraint. No subtitle line should exceed 80 characters. If a sentence is longer, it's split into multiple display segments, and the timing is adjusted proportionally. Let's look at the implementation planned for the second project. This time, my request was quite clear. After the AI confirmed the necessary libraries with me, it started the program development. This design was more complex, requiring 4 Python files. main.py. This is the starting file, handling parameter confirmation and directing the work of the other files. text_processor.py. This mainly splits the script into sentences and, after receiving the audio timing, adjusts the subtitle display based on the maximum character limit. audio_generator.py. This performs the text-to-speech conversion, detects the length of the generated speech segment, and combines all the received audio clips into one complete audio file. srt_generator.py. Its job is to take the input text file and the time lengths for each recognized sentence, adjust the time tags, and finally write the subtitle file. Once this program was finished, it was a huge help. I can now use it to handle the text-to-audio conversion, and I don't have to worry about the subtitles having incorrect text anymore. That's all for this video. Talk to you next time.